Hey everybody, how's it going? This is Our House 21 here, and it's time for another bearing benchmarking. So here you guys see I've got my nice new Traxxas XO-1, which I'm in the middle of doing some serious upgrades to. And one of the first ones that is on the plate is a Boca ceramic orange seal bearing upgrade. But before I do that upgrade, I want to get a good clean benchmark of how much mechanical drag is inside of this this drivetrain. So you guys have seen me do this before. I've got my power meter set up in line. Now this guy is wired from the factory to be set up for 6S. So I have to do some pretty interesting maneuvering here with power leads and hooking up a jumper cable and all sorts of other stuff to enable me to run just 3S for this benchmark. But, you know, that's the configuration we're in right now. Everything's all set. So, let's go ahead and power it on. You'll hear the battery beeps. There you go. All right, let's do that one more time so it's nice and clear. Nathan's helping me out here. All right, so you see, got 3 beeps, so we're all good to go. So the power meter is nice and in frame. So we're gonna go ahead and I'm going to do this the same way that I've done other tests. So if you can see, you've got, excuse me, Nathan. So I'm going to do this the same way I've done the other test, where I've got my little power meter in line back here. So let me see if I can get this so you guys can actually see it. Okay, so I've got my power meter in line here. So I'm going to try to prop this up so you guys can actually see it. I don't have my receiver all tucked away yet because I'm still in the process of getting some things together. So there we go. Is it in frame? Not really, but it's good enough. So I'm going to do like previous test. I'm going to take it down to I'm going to take it down to about 3.8 volts per cell, which is about storage charge. And we're just going to watch the battery, watch it go down. So then I want to take this data and then compare it to the final data, and that's going to tell me what my energy loss is altogether. So this is the XO-1. I'm pretty surprised has a really nice smooth drivetrain. So it seems to be fairly low loss. So we're going to see, we're going to see the differences. I'm pretty sure that the ceramics are better. The last 2 tests, the ceramics were significantly better. But let's go ahead and see what we can do here. So as you can see, we're at 12.54 volts, and we haven't pulled any current yet. So let's go ahead and start doing this.
Sorry, Daddy.
It's okay, Nathan. All right, so a couple things to keep in mind on that round were so because this is an XO-1, the ESC is actually locked right now, which means that it's limited to half speed, which is a way of saying that the wheel speed is only about equivalent to 50 miles an hour. So you saw that there was good ballooning going on there. However, everything was still nice and smooth. So because this is a different ESC and it's a different system, I can't necessarily compare it to the previous test. That's why I'm just doing it in this configuration, and so the day should be good. So some things moved around a little bit on me there, but I'm going to go ahead and everything seems to be good. So let's go ahead and goose it again, and let's keep it going.
Sorry, Daddy.
It's okay, Nathan. Nathan accidentally kicked the tripod, so we reset. You okay, Nathan? Okay, let me try to get this guy up here. All right, let's keep going. Okay, I'm going to stop for a second and check some temperatures.
Sorry, Daddy.
Nothing to be sorry about. Okay, so I'm just going to check the motor temperature to make sure everything's good. And the motor temperature is only at 89 degrees. So, and spare temperature is at 82 degrees. Pinion temperature is at 81 degrees. So this test is basically not even warming up the XO-1, which is good. You shouldn't really expect it to, but you know, it's always nice when you're doing this kind of stuff just to give a double check, just to make sure everything's okay. Because if you had, let's say if I had a bad bearing in here, for example, then the temperatures could be spiking and bad things could be happening. So, all right, so because this is a much slower rate draw, or it's only basically running half speed of what Dizzy was running during this test, it's going to take a while. So I'm just going to go ahead and kick it again. I'm going to go ahead and run it down and collect the data. All right, so I brought everything back down to basically 3.9 volts per cell. At that rate of current draw, it really wasn't going to, it was going to take a while to get down that last tenth of a volt. So I think this is good enough. We have good baseline data. So we saw that the power, you know, at the end was averaging, well, it went from between 80 and 90 watts, you know, with this particular setup. So this is good baseline data. So now I'm going to go ahead and blow this thing all apart and go through the whole process of converting this to full Boca bearing orange seals. So orange seal ceramic bearings. So you'll see that entire process as my son plays video games very, very loud in the background. And you'll see, I said I'll show you everything, show you all step play by play, and then we're going to get back together and then we're going to redo the baseline. And okay guys, so you can see that the power basically went from between 80 and it started off at like 80 watts drag and went down to like 70, you know, which, you know, doesn't seem too bad, but you have to also take into account that this here is running 3S with light gearing. So it's really not, you can't really compare these numbers to what I got from Dizzy or Slade because they were geared for much higher gearing. But I still think that this RPM range should give us good qualitative data or good quantitative data that we can compare. The temperatures, you know, this thing barely even broke a sweat. It barely even knew it was running. So you see the full process here coming up of how you go in and do a complete bearing swap, front end, rear end. So just back off for 1 second. There's a lot of bearings in here. I mean, there's bearings all throughout the front end, including the wheel bearings, inside the differentials. Same for the rear end. Then there's also support bearings that are, you know, basically holding the driveline in place. And then just to also add to it, there's also 4 bearings down here inside of the actual steering. So I'm going to go ahead and take all these guys out, put it back together, show you the full process, and then repeat this benchmarking, and we'll see if we can notice any difference in the data. All right, so until next time, Our House 21 signing out. Remember the mantra: fly, fix, fly, break it, fix it, do it all over again. Remember to check me out on all the social media aspects: Facebook, Instagram, you know, so on and so forth. And you know, remember to get out there and break it and fix it and do it all over again. Our House 21 signing out. Peace.